Hello everybody! In the previous video Human Knowledge, we discussed simplified description, what do we plan to consider as knowledge, and what is the purpose of the knowledge. We also used diagram to clarify how humans' cognition leads us to knowledge as a target of cognition, leads us to motive or subject of the need, which is raw data to perceive via human senses or existing knowledge for further thinking process, which eventually leads us to activity, perceiving data and or generating knowledge. It's time now to continue with the current video through science lenses. This one is the first part, so don't forget to watch second part after this one. We will discuss possible approaches of gaining knowledge. We'll pay a little bit more attention on scientific approach as one of them, and how is it different from others. Ready to go? Do you remember my story from the second video starting point about me participating in 5-day technical training in my work? Key point was that upon finishing that course, I realized that I gained even more useful knowledge during the training in the very clear, packed, structured way, if compared with information which I learned throughout my whole previous year of personal reading and practice at work. When I was trying to analyze what may contribute to such training success despite its very limited time, answers showed me similarities between the way how knowledge was provided during training and scientific approach of collecting and describing knowledge. That brings me to an idea that science allows to collect and provide information very effective way. What is science, scientific approach, and why it may be so effective? From the very high altitude, science is the human activity field aimed to form and systematize knowledge about the reality. I also would like to quote here that the goal of the science is to build observer-independent truths about the world independent of us. Such systematized knowledge pretends to be trustworthy and reliable. Let's check why and how. And let's start discussing with few terms and some background information that our modern science is based upon. On June 2017, I visited Kirby Science Discovery Center in Sioux Falls, South Dakota. There were a lot of very interesting showpieces presented. One simple but very effective masterpiece magnetized my attention. It was a vacuum chamber to demonstrate experiments with sound and wind in a vacuum. It was airtight bulb made of glass with possibility to take air out of it to drop air pressure significantly. Inside this bulb, among other things, there was a bell constantly ringing when needed, and you can clearly hear this sound initially. While an air pressure was dropping down, sound was gradually disappearing while the bell was still moving, meaning potentially generating ringing sound. One of the ideas of such device is to show that sound can be transmitted only in certain medium, like air for example, and there is no possibility to transmit sound in a vacuum. This knowledge is needed to discuss our next idea. When we think about people exchanging information using their voice, initial condition, starting point of our communication is the existence of an air surrounding us. Having air around, you can send out words so your opponent can further construct some meaning out of what he/she hears. If there is no air around, there will be no exchange of information between humans by means of regular conversation. So air is the starting point to make verbal communication happen. Moving on to the main topic of this video, science. So what is the very starting point for scientific thinking? It's time to talk about presuppositions which science is based on. Presupposition, in general, is an assumption or belief that requires to reach particular conclusion and yet it cannot possibly be proved. Many of us, including even scientists, might be surprised about beliefs underneath of science. But I would not immediately be scared or skeptical and put science at serious risk because of that. Moreover, I personally, in general, would vote for science. But we need to discuss and clarify this starting point a little bit. Two main initial science's presuppositions are: physical world exists, and our sense perceptions are generally reliable. So when my friend tells me, "I see you standing on the stage and playing the violin," we both assume, even without consciously thinking about it, that world around us exists, We have physical building with a stage. We have my friend, me, along with some violin exist in this world. How things interact with each other can be analyzed, for example, by my friend's sense perceptions, like vision and hearing. So his vision perceives a stage, me standing on a stage and holding a violin. His hearing receives specific sounds to further understand that I'm not only holding and shaking violin, but also playing it. If we cannot accept and believe scientific presuppositions underneath this science, we cannot trust the whole science at all, because science is based on its presuppositions. Presuppositions are like a basement for a building. This whole building rests on a basement, and without basement it would go underground soon enough. But presuppositions are chosen carefully, properly disclosed, and legitimated by appeal to common sense and sincerity. By the way, it's done just once and for all scientific inquiries. First step of disclosure of both mentioned and other scientific presuppositions is to provide common sense knowledge about the world called physical reality check, which is: it's rational, true, objective, realistic, and certain that moving cars are hazardous to pedestrians. We will discuss terms rational, true, objective, and realistic a little bit deeper in a moment. Now about reality check itself. You may be skeptical and attack reality check disclosure and consequently attack science, but you should realize that you're first of all attacking common sense as well. And I'm not sure it will be against your survival instincts if you try to stay on a highway full of speedy cars. As I was already mentioned, presuppositions cannot be proven, by the way, neither can be disproved. Let me quote. So, science is built on faith, and you have two faith choices: by faith to accept science presuppositions, or by faith to reject science's presuppositions. This choice is not between faith and non-faith, but between one faith and another faith. Science's presuppositions yet cannot be proven but are unproblematic, at least for some people. So it's up to you to decide, do you accept initial science's presuppositions or disagree? Like air is needed for sound from ringing bell in museum's vacuum chamber to reach human's ear from my example earlier in this video. Analogically, presuppositions about existence of physical world and reliability of our sense perceptions are the main needed starting point to build the whole science on the top of it. In case you agree with such presuppositions, please keep it in your mind and we can move on. Another thing that I would like to mention at the beginning about science, it's about certain restriction set by scientific community, which narrows down scope of scientific thinking. Historically, it happened back in 1860s, and to be precise, it was published in Oxford English Dictionary, that science is considered as physical and experimental science, to the exclusion of theological and metaphysical. And such setting restrictions still relevant nowadays. In other words, discussing religion is out of scope of scientific thinking, and metaphysics as well is out of scope of scientific thinking. Oversimplified metaphysics relies on forms of philosophical analysis that depends on pure logic and reasoning in our mind rather than experimental methods, which deeply interact with the real world around. Metaphysics, in most cases, allows you to construct lots of theories just in your mind and may look extremely strong and logical, but for example couldn't be proven by reproducible experimental results. That's about metaphysics, which science does not care of. Analogically, it can be compared with different geographical habitat. Fishes live in water while humans live on land. Same way, science historically sets own borders and focus on physical experimental activities, taking certain things away from its borders. Who knows, maybe it will be changed over the time. Okay, to wrap up, please keep in mind not only scientific presuppositions as a starting point, but also such historical borders. Now it's time to discuss few terms which are very important to scientific thinking. We already mentioned them in our reality check. These terms are rationality, truth, objectivity, and realism. They are very important for us to spend few minutes. Rationality. Something to be considered as rational means that it's making sense, appropriate, required in accordance with some acknowledged goal. A rational belief is not an accidental random guess, but rather is a justified conclusion based on specific reasons and evidence. Rational methods of inquiry use reason and evidence correctly to achieve substantial success in finding truth. So, for example, if you have some illness, you may imagine rational agenda to find appropriate doctor with good recommendations, if possible, make an appointment, visit doctor in person, provide all relevant evidence of your health to such doctor, and assuming doctor's qualification is relevant, receive treatment plan from him or her and carefully follow this plan in order to fix your health issues. It definitely makes sense, appropriate, required in accordance with your goal to be healthy very soon. In other words, it's rational. But it's kind of irrational in the meantime if you would buy assumingly needed medicine right in a doctor's office for the amount of the whole your annual income, without verification how proper is your price for such medicine, or without checking second opinion with another doctor to be sure that there are no other cheaper alternatives to reach the same result. Rationality is needed and claimed for scientific thinking and methods. Next term is truth. True statements correspond with reality. Let's imagine that you are seeing flying red airplane right now yourself. What do you think about the phrase "I see red flying airplane," which you are telling over the mobile phone to your friend? Do we consider such your statement as truthful statement? Of course it's true, keeping in mind our presuppositions about physical world existing and your vision generally reliable. But in case you decided to cheat your friend and tell him "I see blue jumping alligator" instead, while actually seeing red flying airplane, such your statement about alligator cannot be considered as a true one. Remember that the facts about the world determine the truth of statements, but not the opposite way. Jumping alligator in your mind cannot replace real physical airplane flying in the sky. It will be still airplane above you if you share not truthful statement. When we talk about truth, external physical world of objects and events corresponds with internal mental world of perceptions and beliefs. I love this phrase. When it comes to scientific truth, reality has all the votes and scientists have none. Scientific truth is neither defined nor determined by opinions or votes, but by the objective state of nature. Because true statements correspond with the objective reality, we need to discuss objectivity and realism in a brief. So the next term is objectivity. Objective knowledge is about an object rather than a subject or person who knows it. So for example, melted magma coming out from active volcano to the Earth's surface has very high temperature. To be more precise, from around 750 Celsius degrees to 1200. Which is above 1300 Fahrenheit and below 2000 Fahrenheit. This high temperature fact about magma has nothing to do with persons who do or do not hold this belief, because objective beliefs are about objects themselves. For example, magma with its high temperature. Objective beliefs are not about the persons expressing beliefs. Doesn't matter is he volcanologist, geologist, accidental volcano observer, or just reader without specific background knowledge. The truth or falsity of an objective belief is determined by the belief's object, such as magma and its temperature, at a time of coming out and reaching Earth's surface. This reflects priority of reality over beliefs. Another interesting thing about objectivity is that objective knowledge is potentially achievable by literally every human. So experts in volcanology can collect temperature evidence of magma with certain instruments. But it doesn't make them unique persons who alone can make such measurements and know such facts. I would not recommend you to measure volcano activity due to dangerous high temperatures, but theoretically, any person equipped with certain devices can do that. If someone knows fact, so any other human can learn it. One interesting outcome in connection with objectivity is that science is public and shared. We will discuss some features and criteria of science a little bit later. Last term to mention, realism. So when we talk about the physical world, philosophical theory tells us that both human thoughts and independent physical objects exist, and that human can interpret physical world clearly and reliably understandable. The grounds of realism for science is based on presupposition that we have informative contact with physical reality around us. Natural or made by someone real objects can be the only restriction for our human sense perceptions. You can see, touch and smell objects around us. You can sit on a real chair in your kitchen while eating real food, lay on real green grass under a real tree in a park. So such presupposition is basic for scientific intention to collect experimental observations and data. We just discussed four important terms: rationality, truth, objectivity and realism. They are all bases for scientific thinking along with presuppositions underneath all scientific thinking. What we have discussed in this video through Science Lenses Part 1. Science is human activity field aimed to form and systematize knowledge about the reality. The goal of science is to build observer-independent truths about the world independent of us. We mentioned presuppositions, which science is based on. Two main of them are: physical world exists, and our sense perceptions are generally reliable. If we cannot accept and believe scientific presuppositions, we cannot trust the whole science. For easier accepting presuppositions, we introduced common sense physical reality check about moving cars being hazardous to pedestrians. Another important mentioned thing was defined narrow scope. Science is considered as physical and experimental science, which excludes theology and metaphysics. And at the very end, we discussed rationality, truth, objectivity and realism terms, which science claims to heavily use. Let's move on to the video through Science Lenses Part 2, where we will discuss features, criteria and principles of science, as well as we will touch natural humans' way of thinking, which may lead to errors in reasoning and false conclusions. Since scientists are human, we need to realize that such issues are possible, so we need to think how to avoid these issues. See you in the Part 2.